Okay, this video I'm going to try to keep relatively short also. Solving absolute value inequalities. Inequalities, right? Keeping in mind inequalities can be less than, greater than, less than or equal to, or greater than or equal to, right? Inequalities not equal to. Um, all right, so let's try this. First off, if you don't mind, maybe take a second and copy down these rules. Let me read them to you quick and then copy down these rules, and then I promise we'll make sense of them. The first one is that the inequality that the absolute value of ax plus b is less than c, for c is greater than 0, means ax plus b is between these two values, is between negative opposite c and c. If you don't mind, just trust me what I'm saying, but keep in mind that what we want to talk about here is that it's between these two values. Now, the inequality that the absolute value of ax plus b is greater than c means that ax plus b is beyond negative c, opposite c, and c. Write it down. Stay with me for just a second, and we can really make good sense of this. So let's get started, shall we? All right. So let's start with this problem right here. Let's solve this. Solve, I don't know, 2x, right? The absolute value of 2x plus 7 is less than 11. Now we wanted less than, so with less than we say it's going to be between. So this is the condition that we're looking to find right here. So how are we going to solve this? Just like this, we're going to say this, that 2x plus 7 is actually greater than negative 11, but less than 11, right? So we could start, we're going to solve it just like this as this inequality. What I would usually do is break this into two different problems, but we don't have to, so let's just do it. I'm going to add negative 7 to both sides, if you will. The way I'm looking at this right now is I'm looking at this as this is one equation right here, and then I'm looking at this part right here and saying this is another equation. I'm just happen to be doing it all simultaneously, right? All right, so negative 7 here, if you don't mind. So here we get negative 18, right? Negative 18 is less than 2x, which is less than 4, right? Going to divide everything by 2. Again, I'm doing this up here. I'm just pretending it's this right here, so divided the whole thing by 2, right? So let's look and see what we get here. And we get 2 divided by 2 is just this x here. 18 divided by this 2 is 9. And this 4 divided by 2 is 2. So, oh, and this was negative, wasn't it? Sorry about that. All right? So we know that any x value between 2 and negative 9, not including either one, will make this true, won't it? All right. This is what you can do on your own time. If you don't mind, try some values, plug in some values that are in between these two numbers and see if it doesn't make this condition true. All right, for the sake of time, let's try to move on to just one more one. So let's try to solve this one, please. So solve this. So this is our second example. Solve the absolute value of 3x minus 2 is greater than 8. And if you remember what this one is, if you go back to the top and look at the rules, it says that we're going to find that our answers are beyond either side. So it's going to look like this, isn't it? It's going to look like this. It's going to look like this. I'm going to take this 3x minus 2, so 3x minus 2, and I'm going to say is less than negative 8, right? Because that's opposite of c. And 3x minus 2, wait a second, I'll do it here, sorry. 3x minus 2 is greater than 8, right? That's beyond the left or the right hand side, right? And we just start doing this work. We're going to solve for this x value here. Remember, we're going to solve for x to find out the x value here and the x value here. So how are we going to do that? We're going to add positive 2 here, positive 2 here, and we'll get 3x is equal to negative 6, right? Whoops, is less than, come on boy, it's less than negative 6. Do the same thing here. We're going to add 2 here, add 2 here. We get 3x is greater than 10. Isn't that right? Going to just keep solving, keep doing algebra here. Going to divide both sides, everything by 3. So divided by 3, divided by 3, divided by 3, and divided by 3, because we're going to get more than one solution here, right? We're going to get this solution set. And x is less than negative 2. And over here we'll get x is greater than 10/3. So in this case, this is what our answer looks like. Our answer looks like this. I'm going to go back and fill in the other one what that would look like also. We have negative 2, right? So negative 2 is this left boundary, so negative 2. Right? And we're not going to count the negative 2, so negative 2, right? And then everything to the left of it, so there's the outside boundary. And then 10/3. 10/3 is somewhere between 3 and 4. So let's, I don't know, put it here. 10/3, right? 10/3. And does 10/3 count? It does not count. So we need to make a hole there, and it's all those values here, right? So this is the graph of the solution, right? Of that, right? Let's go back up and look at this one here. This one here looks like this, doesn't it? It's all these in-between values. So here's our line. Here's our number line for this one up here. Here's our number line. And what we're going to do is we're going to go from negative 9. Negative 9 doesn't count because negative 9 is not greater than negative 9. So negative 9 doesn't count. And the notation of it is just to leave the hole open there. So that's negative 9. And then we're going to go out to 2. Maybe 2 is here, I guess. So here's 2. And remember, we want all the area in between. So there's the graph of that set. Okay? All right. Good work, you guys.